Okay, so what fractions are we working with? What are we adding together?
5/3 and 1/2.
3/5 and 1/2?
Yeah.
3/5. It's very common to flip-flop those and end up with an improper fraction, but it's really a mistake we have to watch out for. 5/3, no waving.
It's 3/8.
And 1/2.
It's 3/8. No, it's right here. Oh.
That's one we're on. Okay, you got that one. So let's skip down. Yeah, let's skip down to number 4 then. 3/8. That one's a little harder too. Plus 1/2. 3/8 plus 1/2. So what we need to do is we need to find a way to split these denominators up evenly. So if we make our multiples list, we've got 2, 4, 6, 8. And we know 8's going to be on both because 8 is a multiple. 1 times 8 is 8, right? So those two multiples lists give us our common denominator, and that's going to be 8. Does that mean one of these fractions is good to go? Yeah, totally. This fraction is good to go. Yay. Good to go. Smiley face. So what we need to do with this 12 is put it through that machine we built, right? We need to take our 1/2. We need to multiply it times a fraction. That's one number over one number, a fraction equal to 1, because multiplying anything times 1 doesn't change it. And we know our denominator needs to equal 8. So we set this up with missing numbers. Now, we know how to use these missing numbers. When we look at this blank, 2 times something equals 8. We know what that is, mental math, instantaneously, correct, sir? What is it? 2 times blank equals 8. What's blank? 4. We know 2 times 4 equals 8. We know that's true. We all graduated 3rd grade. We're cool with that. Yep, already getting ahead of me. We know to make this fraction equal to 1, if we broke something into 4 pieces, we have to keep all 4 of our pieces, right? That means we're multiplying by 1. It's just 1 that looks a little different. We're being a little tricky, being a little sneaky, right? Now, when we look at this top, we know to multiply fractions, because we can learn it in 30 seconds, we just multiply it straight across. So take this numerator times this numerator, we'll get our new numerator that's split into 8ths, correct? What is it?
4.
4. We built this machine because your brains are totally wired to look for those blanks and know how to fill them in. This looks like this. We had halves, right? We had 1/2. We cut it 4 times. One cut, 2 cut, 3 cut. 4. So yeah, it's 1, 2, 3, 4 cuts made in this now, right? Do we have 8ths now? Yes. We cut that 1/2 so that each of the 2 pieces would be cut up into 8ths. So we took this, and this half is cut into 4 pieces, and this half is cut into 4 pieces. Each half is each cut into 4 pieces because we multiplied by 4. That means this 1 turned into a 4, and this 2 turned into an 8. Now, we have another fraction that's good to go. And if you want, can you set up that addition problem and rewrite everything? Totally. But also, if you want, can you look at the 3/8 and the 4/8 and go, oh, 3 and 4. What's 3 and 4? Put them together. 7. What's our denominator? 8ths. Answer the question? 7/8. Okay, since we're doing this on YouTube, chill for a second. I'm going to show you guys the Moby Max way too. So, 3/8 plus, no. We're going to do the same problem over again. Maybe that way too. You guys can see how it works. I'm not going to force you to use the Moby Max way, but if you get it and all of a sudden you're like, oh, it's a lot less writing. And that did happen to a couple of people today. So we got the same question. 3/8 plus 1/2. In order to find a common denominator, not the lowest common denominator, but a common denominator, you multiply your 2 denominators together, right? We know 16 will work for a common denominator. 2 times 8 is 16. Right? We multiplied this 2 times 8 to get 16, right? Right?
Right.
Chill. Share your space. It's all right. It's only another minute. So if we already multiplied this 2 by 8, does that mean we need to multiply the 1 by 8 as well?
Yes.
Yeah. We skipped that part with the MobiMax way where we said multiply by 8 over 8. We did it mental math because we've already got an 8 sitting over here. So we multiplied this way. Now we took this 8 and we multiplied it by 2. Right? 8 times 2, 16. 8 times 2, 16. Now we need to multiply, since we already multiplied this 8 times 2, now we need to multiply this 3 times 2. What is 3 times 2?
3 times 2 is 6.
6. That means now we changed both of these fractions to equivalent fractions without all the extra steps. Does that make sense to you? Kind of, yes, maybe. If you're a mechanical kind of thinker, this might make sense to you. To me, this is not my favorite way. But now, do we know we have what pieces to add together? Yeah, we've got 6 sixteenths and 8 sixteenths. We put those together, 16ths, 14.
How do you figure out that it's a 16?
8 times 2, 16. Multiply the two denominators together. And then since you multiplied this 8 times 2, now you multiply the 3 times 2. Since you multiplied this 2 times 8, you multiply the 1 times 8. That's a hot mess looking one, though. Yes, it is weird. And I will tell you this. If I walked you through this way twice and you still don't get it, don't use it. The other way, where we set up that variable to times something over something, we know what our denominator needs to be, figure out the denominator, put the same number in the numerator, then multiply across. That way, it's super visual. You can always see your pieces, and if you can always see your pieces, you'll never go wrong. Because if you can always see your pieces, you'll know when you mess up. You'll look at it and go, "Oh, that looks weird." And if it looks weird, you know probably something got messed up. Correct? Cool. Feel like you're ready to try these on your own? Okay.
Kinda.
Kind of is good enough to start with.